Hi friends, this is Roland. I'm back with another Houdini tutorial, and in this one we're going to take a look how we can rig a piston using KineFX. Let's take a look at the setup that we are going to build. So I have this piston here that's actually a CAD file that I converted and imported to Houdini, and we will create this kind of an animation. And when I started with this project, I thought that it is way simpler and way straightforward than it actually is. So we have to do a few tricks here to get this right. The setup will be the following. First of all, we are creating a skeleton for this piston. And to create a skeleton for a mechanical rig, you have to be precise. So we will extract some centroids here. So let me quickly show you what we are going to do here. We're going to extract centroids exactly in the positions where we want the joints to move. So these blue points are our centroids that we will extract from our model. And we will then use these centroids to build our basic skeleton. So this is the basic skeleton that we have here. You see that there are two independent bones here that are not connected in between. And then we have to create this very specific motion of a piston. That means that the part down here will rotate, of course, if we take a look at that quickly. So the part down here should rotate and should just take the upper part with it. But the upper part should not change its orientation, and it should really stay in place at this joint here. And this was actually a bit of a challenge. We have to do a little bit of workaround here using some constraints and a Rig Attribute VOP. So that's one version that I built. This includes a little bit of matrix calculations. It's not too complicated. It looks way more difficult than it actually is. And I also included here a second version where I just transformed the matrices into the usual vectors, into the transform vectors, or translation vectors, I should say. And then I did basically exactly the same calculations. Both of these setups work exactly the same way and do more or less the same. They're just two different approaches. And yeah, then I'm just capturing all this geometry, and here I'm just unpacking it to add some material. And this is actually the final result that we have. As you can see here, if I play this animation, that's what we have, and everything is in place and it's working nicely. So if you want to grab the project file, it is available on Patreon and the link is in the video description. And now let's get started with this setup. So I will just start out from scratch here with my model. And let's take a look how we can extract the centroids. And therefore I want to select a few primitives on my object and then just delete them or solo them. So let's do that. Let's select our transform here. And I will start up here on this piston head here. And I will just hold down A and middle mouse click on the inside of this tube here. That tube is really in the middle of our object here. So this will work nicely. And now I can just press delete. And I do that with the mouse over the viewport, then we will blast this away. And if I go to delete non-selected, then I only have this tube left here. That's pretty good. Now we can just choose extract centroid. And we have to set this up to run over the detail. And now we have a centroid point. If we take a look at the position of this centroid, you see that it is very slightly offset on the x-axis. And actually, I don't want that offset. I want to make sure that it is really in the middle. I only want to offset these points on the y-axis, and I don't want to have any offset on x or z. There are multiple ways how you can achieve that. I will just use a quick point wrangle. So let's add in a point wrangle, and let's just set this vector here. So let's bring this into the middle here, and let's say at p equals, and now we will just set a vector. And I want to set the vector to be 0 on x at p dot y on the y. So we will take over the initial value, and we will also set it to 0 on the z component. I will apply an accept, and you see now this corrected the offset here on the x value. Now we can do exactly the same for the other parts. We'll go down here and select this inner tube here, this one here, hold down A and middle mouse click, press delete to blast this out. I just have to rewire these. And now I can just copy these two nodes here. Hold down Alt to copy them and put them in here. And now I should have another centroid. The only thing I have to do is, of course, switch this to delete non-selected. And this will now work. You see that this is also only offset on the y-axis. Let's do this one more time. Here, down here at this axis, it's not that obvious which one I can use here. So I could use probably either this tube over here, and let me actually add in my wireframe, then we can see this a bit better. Or I could also use this tube. I think that both of them should work. So I could also use this small one here. Let's use this one actually, because this is probably more precise. So let's go in here to the selection tool, press S, and then I will just press A, hold down middle mouse. I have to activate my transform actually. Hold down A and then middle mouse click and select this tube. Blast it out. And quickly rewire our setup here. Turn this to delete non-selected. And now I will just use exactly the same thing. So of course, if I just extract the centroid now, as you can see here, now this is offset on, in this case, the Z axis, you know. But when I use my pointer angle, then of course this will snap back into the middle here. And now if I just merge all of these points, let's take a look at these and let's actually take a look at my object. Then we should be fine. Now I could also extract another point here, and I actually did that in my first setup up here on top of my object. And we can do that, but it is actually not really necessary. But let's do it just because it is also in the file that you can download. Let's extract one more, and I will actually put this in front here because it is the top point. So let's grab it just from here, and there we'll go to the front view. And I will just grab one of these points on the top. So this one here, exactly this. Let's grab this point here. Let me see whether I can grab it. Yeah, I can grab it. And now I will just blast this out. So again, I have a blast here and I actually grab 2 points. So let's see what happened here. I just want to grab one actually. Let's say delete non-selected and let's go to our perspective view. Oh yeah, of course, I didn't turn on select only visible. So I have to turn, or I have to just delete one of these, and I will just delete the number out of my blast node, and I'm left with only 1 point. If we take a look here, this also has some offsets, slight offsets on the X and on the Z, of course, because it was not in the middle of the object. And this time I don't need to extract any centroid. I will just copy over my pointer angle and set this into the middle of our scene. Let's add this to our merge, and I will just make this a bit more organized like that. If I select my points now and template my object, go to the front view, this way we can see whether everything is in place, and this looks nice. If we now go to the right view, you see that here everything is in place where it should be. So I have my points, and now I can create my skeleton. To create the skeleton, I just want to use a skeleton node, and we are working with KineFX here. And with the skeleton node selected and the handle tool activated, I can now, if I set this to create, I can create bones, and this is pretty handy. I want to activate point snap in this case, and I want to deactivate my model quickly so that I do not, snap to one of the points on my model, because actually, as you see, you can also snap to points from objects that you have templated in your viewport, but I don't want that, so I will just turn it off for a moment. I know that what I will do here, I will just create 2 bones here. One starts down here, this would be our point number 0, and goes to the next one. Then I just hit enter here, and then we'll do the same up here. We'll start here and go to this next one and hit enter. Now, if I template this again, you see this should be the setup that we need. Now I want to check the orientation of these because this is important. We want this to rotate in the right direction. So let's turn off this point snap, and with our skeleton still selected, I will go to modify now. I can right click on one of the points and say display joint axes. And actually it doesn't look too bad. So they are quite nicely aligned, but you see that they are not all in the same direction. We can get away with that. It's not really a problem for us because we only want to animate this point down here. But to make this a bit nicer, I will just reorient these, and you can do that using a construction plane. Now, because we are here in the middle of our scene and everything is nicely aligned on one axis, we can just use a construction plane that is, exactly looking like that. So that's what you want. If your construction plane is oriented the other way, then you just go to this construction plane menu by holding your left mouse button, go to set construction plane, and then just use whatever you need, whether it's flip C front. If I do this now, you see this is not what I need. So I have to come down here and set this up so that it is working. In my case, now it is working. That's exactly what I want. I want my construction plane to be exactly aligned like this. So that's what you also want to do. Now we will go to modify, as I said, and we will just choose all our points by holding down Shift and clicking on these. And then you can go right click and say Orient Joints. And you see now all of them are pointing in the same direction, and they are actually orientated along our construction plane. So we can turn this off, and this is good. Now I want to create my animation. So let's add in a rig pose here. And I just want to animate point number 0, this one here. So I will just grab this, and this will add my point in here. And I want to rotate it on the x-axis. So I can put in an expression here, time times, let's say 200. This should create a nice rotation, as you can see here. And now we are rotating in this direction, and that's fine. Sometimes the viewport does not update correctly, as you can see here. So we can see the axis of our points, but this one is not moving with it. If you run into this problem, then you just go up here to labs and go to reset viewport. And then maybe this helps. Let's take a look. Yeah, now everything is moving nicely together. Now to actually see what we are doing, we can already set up some capturing here from our objects. And in this case, I just want to capture, let me move this over here, and let's also drag this over here. In this case, I just want to capture this geometry as packed geometries because we have no deformation here, and it's a bit easier that way. So to create a packed geometry from my meshes here, I will use an assemble node. And with the assemble node, I just click create packed primitives. And now if we middle mouse click, you see we are left with 9 primitives here. So the 9 parts of our object, and that's pretty good. Now I can just select these as a whole. If you go in here, select the primitives, you will get these parts like so. Then we have this capture packed geometry node here that we want. And on the left side, you put in your geometry. On the right side, you put in your skeleton, but in the rest state. So we will use this one here. And now we can set this up, a manual capture. Now let's select all the objects, all my primitives that I want to actually link to my point 0. So all of them that should rotate with it. And if we just template this, I cannot really see it now, should switch to the wireframe. That doesn't really help. So let's just not do that. Let's just capture it like so. I know what I need. I will just use this one here. Select it, hold down Shift, then this inner tube here, this part, this axis, and I also want this over here to rotate with it. So these are the 3 that should rotate directly with my point number 0. So I can just hit enter with my mouse still over the viewport now. Oh, this didn't work because actually I made a mistake here. I have to do it like this. I have to click this one here. And now let's do the same here, what I did before. Now we can hit enter and you see that these are now selected here. And now I can just choose point number 1. Now they are captured, and now I just have to add in a bone deform here. So with the bone deform, we will see the motion. The first one, I need the geometry. On the second stream, I again need my skeleton in rest position, and on the third one, I need my animated one. And now if we start playing our animation, you see that this is already working nicely. Okay, so far so good. Let me actually extend my timeline a bit. It's a bit short here. So let's do it like this. Then I have a bit more time here. Now I want to link this part here in the middle, so this connector here, to my point number 1. Let's do that also. Let's go in here, create another manual capture, and let's again select a few parts here. So let's select this one here. And also there is another one that you cannot really see. It's in here. So I just hold down Shift and select this also. And in the middle, there's also one that I want to select, but I cannot really grab it now. So I will do this in a different way. I will just press Enter now with my mouse over the viewport, and this will put in these numbers. And I think that the other one that I need is actually number 6 here. So I will just add it in like this and then choose point number 1. And now let's see what we have. And yeah, you see this one here. So this, I don't know what it is called. This was actually part number 6 that I added in here manually. So now I have all the parts connected here that I want. And I can now just select the other parts and connect them to my point number 2. And point number 2, if you take a look at my rig here, well, let's do it like here. Here it's a bit more obvious, is this one here. So point number 2, I want to rig, or I want to capture this whole head of the piston. So let's do that. Let's come in here. Let's create another manual capture. And now, because I know that these are 9 parts actually, so we can just put in the numbers here, I guess, but I could also select them. Let's just select it. Let's select what we can grab, and then we will put in the rest manually. So I can grab these 2. I also want this one in here. And I think this is everything. Let's take a look. Yeah, 0, 1, 2, 3, 4, 5, 6, 7, 8. So we have 9 primitives linked. That's good. And this should be linked to point number 2. Now, if we take a look, what's happening here, everything is working. Of course, these are not moving because we did not change anything now on our rig for point number 2. But that's actually the next step. So why did I not really link these two? And there is a reason. Because I have to extract some data from our point 1 here. And let's do it like this. And bring this data from our point 1 somehow to my point 2. I want this point 2 here. Let me turn this off for a moment. Let's make more real estate here. I want this to move together with point 1, but I only want this to move on this y-axis here, so our world y-axis, because you see that my point is orientated in a different way. In this case, it would be the z-axis, but I want to move this on the y-axis. We will stay in this local world space here when we are calculating these motions. Otherwise, it will be too confusing. And that's what we want to do. And therefore, we need to create some kind of a relation between them. And I want to use a Rig Attribute VOP to do that. Let's add in a Rig Attribute VOP here. And let's dive inside. Let's make sure that this is activated, because then we can see our points. And let's just set this up to frame number 1, because then it's a bit clearer what's going on. Now, the Rig Attribute VOP is a VEX builder, but it is a bit different than the usual sub VOP. You see, we have no import and export here, so we have to create these ourselves. And you can do this by clicking in the viewport. And if you hover over a point, you see these 2 options. And if you click it, you can actually access these 2 options. So first of all, if you click the upper one, then you will get a so-called get point transform. This is the input data that just adds the data from your point into the VOP. If you click the lower one, then you will get a set point transfer. So this is the output that will put out the data back to the point with all the changes in between. If we set it up like this, now nothing will change. Everything will stay the same. And we can do the same here for point number 1. So let's do that. Let's bring in our get point transfer and our set point transfer. And if we link this up, nothing is changed, so this is still working. And now we have to do a little bit of thinking what we want to do. I want to actually grab the position here from my point number 2 and link it exactly to the position of my point number 1. In the beginning here, we have a little offset, as you can see here. So there's an offset. I want to calculate this offset. And then when this offset is calculated, I want to link this point to this point and add the offset. Then this point will just move up and down with this one here, and the offset will stay always the same. This is the first step. So let's do that. Now, the thing is, we are here working with X-form matrices, and these are 4x4 matrices. And right now we have no access to this data. So there are a few options that you have. You could now go to matrix to float, and this will bring in this node, and that is a little bit difficult to understand if you never worked with matrices, which I never did actually before, or not really. So I had to watch a few other tutorials. And if we take a look now, this node is not really intuitive, but it will actually show you your matrix. So this is the form of your matrix. And in a 4x4 matrix, these values appear. So the first 3 columns here and these 3 rows are just for rotation and scaling. And we don't want to touch these. And the last row here, so the 4th row here, is actually our translation values. And I want to extract and manipulate these. So what we can do here is, let's take a look at that. I actually need to create a float to matrix to convert this back and then link it up here. And let's also duplicate this one here and turn our point 1 data also into float values. Now, if I grab this value here, so it is on our row number 4, the column 2, this one here, this is our Y translation. And if we go in here, we can hover with this, and you see down here, you see these numbers. So row number 4, column 2, that's the one that we want, and we will just link this up. You can also see it if I zoom in here, right here. So 4, 2, this is also written right here. And now I will just feed the position of my point number 1 to the position, the Y position of my point number 2. And now you see something changed in here. The thing is with these VOPs that they display the initial state, so the input state, and the output state at the same time. And that's why we still see our point up here. If I right click now and say, or disable display inputs, you see, if I go out here and make sure that this one is selected, and now I only see the result of this. And that's what I want, because otherwise it's too confusing. Now you see, it does what I wanted. So I wanted to take over the Y position and copy it to my point number 2. The only problem that we have, we also lost our orientation, and that's because I did not connect these here. So I can just connect now all of these first values, just connect all of them, and this will restore the right orientation that we initially set up on our skeleton. So let's just do that. And at some point you see that it starts to come back, and now we have our orientation back. So that's what we have now, okay? This is good. That's something that is pretty good. Now, the next step is to calculate the initial offset value. So before we do any manipulation here, up here, we have this offset value between these 2 points. When they are not animated, when they are not moving, there is an offset. And I want to calculate this distance. There are many ways how I could do that. I could use a wrangle to do it, just before the rig pose. And I can also directly do it in here. So this is also possible. Now the problem is if I calculate my distance in here, it will change because my rig pose is already moving 1 point. So this is not what I want. I want to really calculate the distance between these points before anything moves. I could, as I said, do this also with a rig attribute. I could put this up here. But I think in my case that the simplest way is actually to really calculate this with a wrangle. So let's do that. Let's use a point wrangle here. And I'll just put this directly in here in front of my rig pose. And let's again take a look here. We need two vectors to calculate the distance, so the two positions of our points. So let's create these. I want to create vector P1, that's the position of point number 1, and vector P2, that's the position of point number 2. And then I will just use a point function to read in this position. So I want to take a look at geostream 0, and I want to extract P, and I want to do this from point number 1. And I will just now copy all of this over here, actually with this, copy it down here, and just change this point number. Now, I will create a float attribute that is called dist for distance. And now I can just use the distance function. And the distance function actually only requires two vectors, and we have them in here. So we have P1 and P2. And apply and accept, everything should be fine. If we take a look at our geometry spreadsheet, we should have now a distance attribute here that is now stored on our points. And you see that the distance between these 2 points up here, let's take a look at these. This distance here from point 1 to point 2 is 0.65. Yeah, here it is, 0.65. It's a constant. Now I know the distance between these two, and I also stored it as an attribute, as you can see here. So it is available here. Let's go back to our Rig Attribute VOP, and let's take a look what we can do with this. So right now, and I will set the display flag to this, my point number 2 is moving on the y-axis with point number 1, but we need to add this distance back. So let's do that. Let's bind in our distance attribute, and I will just do it down here. Let's say dist for distance. Let's spell this correctly, like so. And now I just have to add this in, okay? So let's do add operation, and let's just add this in. Let's take a look what will happen. And somehow nothing is happening, and I actually don't know why. So let me take a look why this is not working. Yeah, I think that I forgot something, and I have to change this point wrangle, not to run over the points, but I have to change this to run over a detail, because then it will store it on the details, and then I can bring it in. And you see now this is working. So now I have my offset in here. So I will deactivate this just to show you, or let's deactivate the add here. So this was what we had, this was before adding anything to it. And now I'm adding my distance attribute that I had to store on the detail actually. And now this works. So I have the offset. Cool. So now we think that maybe we're already done here. Maybe this already works. Let's take a look at our bone transform, and let's see what this is doing. It's nicely moving with it. The only thing that we have to do now is to reorient this part here. And this part is actually connected to our point number 2. So if we put in here a look at constraint, so that this point here, our point number, no, let's take it here, that's more obvious. Our point number 1 should just always point into this direction, and it should work, right? So let's take a look at that. To add in a look at constraint, we can also do this directly in our Vex builder here. It's pretty simple. We just take a look at constraint, and in this case, this KineFX one here. I have all my transforms that I actually need. So I have my look from, and I want to look from point number 1. So I will take this X form here, not the local one, the normal one. So let's grab the right one and put it into from. So I took this one here and put it into look from. Then I will take the updated value of my point number 2. So this one here that is already moving up and down, and put it into the target. This is the 2 here. And then we will update our transform of point number 1 with that. So we'll just put this in here into the X form. And if we take a look now at our result, we will see immediately that something changed, and it looks not too bad, The only problem that we have is that this is not orientated the right way, but we can fix this pretty easily by going into the look at and just change this axis here. And you have to try whatever works. In this case, I just had to change the up axis to +y. If we take a look now at our object, it is orientated in the wrong way, as you can see. So these numbers are on the other side. So let's be precise here, and let's go in here and change this to -y. This should actually corrected. It did not. Okay. So then we stay on the Y and change this here to Z, and it also did not do anything here. Oh, that's because I'm on the wrong node. Sorry. I have to activate the bone deform, of course. So let's do this again. You see now I am on the right. No, it's still wrong. Yeah, now it is right. So the numbers were on the other side here. But I have one problem. You see that this is now jumping. So here it jumps and then go one further, it jumps again. So this is not working like this. We need an up vector here. And there is this option here to put in an up vector in the look at. And this also requires a matrix. And we can use the set component, matrix component it's called, set matrix component. We'll just use this one here, plug it in here. And with this, you can just set the matrix component. And you just want to put in one of these axes here. So this is X, Y, and Z. We only care about these three values here, and we don't care about all the other ones. And if we set this to 1, let's take a look whether this already solves our problem, whether this is still jumping. No, you see, it's now not jumping, but I think that it is still not oriented correctly. Yeah, it's still pointing to the other side. So let's correct this quickly. And now we just have to deal with these axes here. Let's see, this should now be the right orientation. And it is, as you see, and we do not have any flipping anymore. So that's good. And again, we think that we are done. This looks really good. You know, if we take a look at our result here, everything looks nice. But if you take a very close look, and we will see this in the front view, and when I activate the wireframe, there is some offset happening. So you see that these two things here are not lined up properly. So our piston head is not really moving in a constant way with our moving parts here. So there is an offset, and this is actually intersecting, and this is not really looking right. So why is that? The problem is, of course, because this distance here between these points, we calculated it as a static value in the beginning. But when our point number 1, this one here actually, starts to move around, then of course the value here changes. And I'm sure that there are some mathematical geniuses out there who could do a very simple calculation to correct this. I have to do a little bit of a workaround here. So I will just correct this by calculating the distance between these two while they are moving now. And we can do this also directly in our Rig Attribute VOP. And we can also do this with these matrices here. So let's take a look what I mean. Let's make a little bit more room here. And the thing is, we have now our 2 points nicely moving. So I have this one here, and so point number 1 and point number 2. Point number 1, point number 2. And I want to calculate the distance between these two while they are moving as they do now. What I can do here now is, I know that my translation values here are actually these values. So 4.1, 4.2, and 4.3. To calculate a distance, I need a vector. I need a vector 3. If you take a look here at the distance function that we have inside our VOP, you see that it requires a vector input from a point. But that's not a big deal. We can actually just use that or calculate that. We just have to turn these float values into a vector, and then we can calculate the distance. That's pretty good. So let's take a look at that. I will use a float to vector node. And in this case, I just want to use the standard one here, so no matrix things involved. And what I will do now is take the updated position of my point number 2. So therefore, I just use the x value, that's this one here. I use the z value, but then I will use this updated one. So I want to use this one here. This is the position of point number 2. Let's put this in here. Now I can just copy this and link it to point number 1. So I need this one here, then this one here, and this one here. This is the position of point number 1 of this one here. And we will calculate the distance between these two. So now I have my static distance over here and I have my moving distance over here. I want to calculate the difference between these two, and therefore I can just subtract them. So just subtract the static distance from our moving distance. Now I have kind of a correction value here. So this is the difference between these two. And I can just implement this now into this stream to update actually the position of point number 2. And therefore I just have to add this in here. So let's put an add here and then drag this in. And this was probably the wrong way around now, because now I actually have a bigger offset. So maybe I made this wrong. So let's take a look whether I can just reconnect these. Yeah, this was the wrong way. So I have to subtract the moving distance from our fixed distance and then add the correction value in here. And now you see that this is working. And if you take a look now very closely, then there's really no offset anymore. So this now really stays in place and is moving nicely around this joint here. Good. This is it. Let's take a look at our final results. Let's go to our perspective view. Let's go out here and let's run this simulation again. And you see that this is now nicely working. And you can, of course, now change the speed by changing the values in the rig attribute and create your motor animations that way. I will not go through the second solution. It's actually pretty much the same as I did here. You can find it in the project if you want to take a look at it. So this is the second version. And the only difference is that I just converted the matrices into transform values. You see there is this extract transform node here, and that will just turn a 4x4 matrix into actually 4 3x3 matrices. So we have the transform, the rotation, the scale, and the shear. And that's really everything I do here. And I do exactly the same calculations you see with the distance binding and calculating the distance between the points and subtracting and adding everything together exactly as we did. But then I have to just reconvert all of these things again with such a node here that is the make transform that converts transform values or 3x3 matrices into a 4x4 matrix. Then we can feed this into our set point function, and this will exactly work the same. So these are the two options that you have. As you said, you can get the project file on Patreon if you want. So I thank you very much for watching, and I really hope to see you next time. Goodbye.